Okay, so what is photogrammetry? Let's start by analyzing the name. First, photogram, which means a drawing made with light, and metry, which means to measure. So, photogrammetry is to measure using photographs. Pictures capture a lot of information of the environment. Look at this image, for example. You can easily understand the depth and the size of what you're looking at. But this is thanks to contextual information. You understand how perspective works, how shadow and light give volume to objects, and you know the size of objects such as people and cars. This kind of information is not very helpful for a computer. But there are other ways to convert two-dimensional images into 3D data, if you have more than one picture. The process is similar to how humans look at the world, with two eyes. By contrasting the information from one eye with the information of the other, the brain can give you a mental reconstruction of the depth and the position of what you're looking at. This is called stereoscopic vision. The same process can also be used with computers. By contrasting two images from different positions, a software can determine the location in 3D space of the pixels in the picture. This is an example of a wooden carving, reconstructed in 3 dimensions using only 2 images taken with a high-resolution camera. You can see the small details, like the cracks and even the texture of the enamel. This is just an example of what can be done with photogrammetry. Okay, so you're probably saying this is a pretty cool technology, but you want to make 3D reconstructions of complex objects, not just bas-relief. First, I would like to analyze how humans make 3D reconstructions in their minds of complex 3D objects. We start by looking with our own 2 eyes in one position, and then we slowly turn it around and start creating a mental reconstruction of the object. All that information is stored in our brain, and it can put it together to create a mental image of this complex 3D object. This is a similar process that you can use with photogrammetry. You take multiple pictures from different positions covering all the object that you want to scan. Here I'm going to show you an example of a 3D reconstruction using a sculpture of a head. I'm only interested in the head, so I will take enough pictures to capture it from different angles, for a total of 22 images. You can clearly see the head appears in all the pictures, and there is only a slight change in position between each image. Every part of the head must appear in at least 2 pictures. The more pictures happen to have the same part of the model, the more accurate that 3D reconstruction is going to be. I will talk about some of the key aspects for taking good quality pictures later, but for now, let me show you some of the results. The most basic result that you can obtain from a photogrammetry process is called a point cloud. This is a set of points in 3D space that represent the position of each pixel in the pictures. The result may appear as a solid object, but is in fact only a set of points. Another useful result is a polygonal 3D mesh. This result is a powerful tool for many creative professionals. This allows anyone to easily obtain a digital twin of any real-world object or environment. The 3D mesh can have great detail and can be exported to most 3D modeling software. Once the 3D mesh has been generated, the photogrammetry software can also project the actual images onto the model. This can produce convincing textures with very little work. The process is done automatically by the software, and although it can be messy sometimes, with a little bit of extra work you can have much better results. Besides creating the texture by projecting the images onto the model, photogrammetry software can also create the normal map and the occlusion map, very helpful for creative professionals. There is another result that can be obtained from this process, which is the position of every camera. This can be exported to other modeling software for different applications. As you can see, the process gives very useful results. So how does it work? Well, let's just say you need good pictures, a lot of computing power, and math. I will not go into the details here, but I will try and explain some of the more practical aspects of the process so you can start doing it on your own. Okay, so in case you're interested in starting using photogrammetry for your projects, what do you need to start? Well, the first thing is a decent camera. Second, you need a somewhat powerful computer. And the third thing is photogrammetry software. The first thing, the camera, I'm pretty sure you have a good enough camera on your smartphone right now. You can get a better camera further ahead, but I recommend that you start with what you have. The same thing goes for your computer. You're probably watching this on a computer that is capable of running a photogrammetry software. And as for the software itself, I recommend that you start with a free option and then move on to a professional option. Besides these three things, you don't really need much else, but I highly recommend that you consider getting a tripod, which will improve drastically the quality of your images, a shutter release that will reduce the motion shakes when you take a picture, and lights, depending on the kind of setup that you're going to be using. This will improve enormously the quality of the images and the end results. Once you have your equipment ready, the second step is to make sure you have an adequate subject and a correct setup. The key aspects is that the subject of the process must not be reflective or transparent and should have enough surface texture to identify in pictures. Finally, you should have a static object and lighting to avoid making changes between pictures. Here you can see what is probably the worst possible object for this technique. It is transparent and reflective. You can see how difficult it is to properly identify the shape in the pictures. Also, reflections make this subject change between pictures. This makes it almost impossible to reconstruct using photogrammetry. The ideal object for the process should have micro-texture, be non-reflective, and have a lot of details that will be easy to identify in pictures, as is the case for this object. Also, having multiple color details would help even more. Another crucial aspect is the consistency between images. You should avoid at all costs changing the lighting and the shadows on the object between pictures. Also, for the sake of consistency, the subject and the environment should not change. So, moving things around or deforming the subject would yield unexpected results and should be avoided. I will talk about some of the key aspects that you have to consider when taking pictures. The first one, and the most important one, is consistency. You cannot change the position of the object, or the environment, or the light, or any parameter of the camera. It has to be consistent between each picture, all of them. Then, make sure you have very good quality light. Enough light to make sure that you take good pictures without a lot of noise, and also that it illuminates the entire object adequately. You should also make sure that you reduce the artifacts in the pictures, like noise and motion blur. Then, make sure you have good overlap between images, at least 50%, but the more, the better. Also, you have to have good coverage of the object. Make sure that the object is at least 50% of the image frame and that you cover all the surface that you want to reconstruct in 3 dimensions. To help with consistency, you have to make sure you have the correct parameters in your camera. The first and most important one is to not change the focal, which is you shouldn't zoom in or out. Second, you should keep the white balance and the focus fixed. Try and use the lowest ISO possible, usually the native ISO, which is 100. Afterwards, do not process the images. This will only destroy the information that the software needs. And finally, avoid using image stabilization. That also deforms the images and causes the process to not work correctly. Proper lighting is crucial for a good result. Usually, the more light you have, the better. The light should be uniform as possible over the area you want to scan. You should avoid shadows on the object, whether it's from harsh lighting or from yourself when you're moving around the object. With the best possible lighting, you have to make sure you correctly expose your camera, avoiding blowing up highlights or crushing your shadows. Also try to maximize the dynamic range of your camera to make sure you have all the details as possible. And it's better to overexpose a little bit than go underexposed. This is an example of why it's so important to have uniform lighting and avoid harsh shadows. To try and avoid clipping the light area, the part in shadows ended up being a little bit underexposed and has more noise. This noise can be seen on the surface of the 3D model after it has been reconstructed. So a more uniform lighting would prevent this problem. This is just an example of what a decent picture would look like. If you zoom in, you see the crisp details and uniform lighting. On this other image, you can see the problem with having a lot of noise. If you zoom in, you see the loss of detail, color, and the appearance of small noise. This other case shows what happens when you have motion blur. This is whether if you handheld with a slow shutter speed or if there's some kind of movement of the camera. This kind of artifacts will have a negative impact on the process and it should be avoided at all costs. Sometimes you might find one or two images that have this problem and they should be deleted before processing. There are many options for the software. I recommend that you start with a free option. The three options that I suggest is first Meshroom, which is a completely free and open source software. Another option is Zephyr, which has a free option with up to 50 pictures. Also, Reality Capture, which is an amazing software, but you have to pay if you want to export the model. But for trying out and understand how the process works, it is all free. Once you have tried the free options, I suggest that you consider purchasing a commercial software. There are different softwares available, but these are the three that I tried the most and I recommend. Metashape and Zephyr Standard are really good for the price, and you can use them all you want just as any normal software. Reality Capture is a bit different, as the way it works is that you pay for the number of pixels you use to generate the 3D model. This can be good for a few tests or small projects, but can quickly become more expensive than the other options if you start to use the software more often or for larger projects. Still, it is a great way to start with minimal investment. Now that we have seen an overview of the process, let me give you a walkthrough using an example. This is the equipment I use. You can do much better, but also you can use much more modest options. Probably the two most important considerations for selecting your equipment is that a better camera and lens will give you more accurate results, and the better graphics card will make the processing go much faster. Let's start with the camera configuration. This must be done on-site to determine the proper camera settings. I did this indoors next to a large window with the curtains diffusing the light. This gave me good illumination. The configuration should be done by looking at the object through the camera. Use your camera's Pro or Manual mode to be able to control all the parameters. First, use the lowest ISO possible. This will reduce the noise of the image and give smoother and more accurate results. Now, you have to choose the shutter speed. You should try and use the slowest shutter possible so to have good exposure, but not too slow, that may introduce motion blur if you are doing handheld pictures. With the proper exposure, you should now set manually the white balance to avoid small changes between pictures. You should also change from autofocus to manual focus and choose the appropriate focus point and keep it during the entire session of taking pictures. Here you can see how much it varies depending on the focus of the camera. This should be avoided to have some consistency between images. You may choose something to position the object on top. This helps with taking pictures. In this case, I chose a paper cup. This will also help with the alignment of the pictures. Place it somewhere you can easily access to take all the pictures, and then place the object on top. I chose a small figure of the Colosseum, which is non-reflective and has a lot of surface detail. Start taking the pictures at a horizontal level and all around the object. Then, change the elevation and take another round of pictures from a higher position. And finally, don't forget to take pictures from the top. I took around 50 pictures of this object. These are two pictures that I took, just to give you an example. You can see the size of the object is relatively large in the frame. The smaller the object, the harder it's going to be to fit the entire frame, but always try and fit as much as you can information in each frame. You can also see the difference between the two pictures. They're actually very similar, and the overlap between them is significant. This helps the software compare the points between the two images and improve the reconstruction. Let's move on and use the software. This is Agisoft Metashape. I will start by dragging all the pictures into the workspace. We now move to the Workflow tab and choose Align Photos. This is usually a quick process, but depending on the amount of pictures, it may take longer. Here you can see all the tie points between all the images that the software found, and also the position of all the cameras. See how concentric the images were taking? This is more or less enough to have a good process. Now what I want to do is position the model correctly. I will change the camera views and position the model so it's aligned with the different orthographic views. At this point, I have to remove all the unnecessary tie points so the software can concentrate on the model only. I will select only the points I'm interested in and then tell the software to eliminate everything else. Now that I only have the points I'm interested in, I'm telling the software to reset the region of processing, and then I will position it correctly so it's aligned with the model. It is important to rotate the region of interest and also to scale it to make sure that the entire volume of the object is within the region. With the model correctly placed and the region of reconstruction correctly aligned, we now move to the next step in the workflow, which is to ask the software to reconstruct the 3D mesh based on the images. This is the longest part of the entire process. Depending on the amount of images and the quality of reconstruction, it can take between hours and days. But in this case, because we're not using too many images and they're not very high resolution, the process took about 2.5 minutes, and that included also giving color to the vertices. We now have a 3D mesh of the model we scanned, but we can move forward to the last step in the photogrammetry process, and is to project the images to create the textures. Projecting all the images onto the model can take some time, but the results are definitely worth it. We now have a high-resolution model with all the textures applied. Now we can choose to export in different file formats depending on the software we want to use it on. You can also choose to export the point cloud, the mesh, or the textures individually. This is the result that you will get for the textures. It is fine for some applications, but in case you need a cleaner texture, you will first need to fix the UV maps. I am using ZBrush. I will clean the model a bit, then duplicate it, and apply ZRemesh to fix it. I then project all the details from the original model. Afterwards, I will unwrap the UVs and then export it to bring it back to Metashape and reproject all the textures. This is a much cleaner texture. This concludes this brief overview of photogrammetry. I hope you found this video helpful. I want to encourage you to start today using any resources that you have at hand and free software. It is a very powerful technology that is very helpful for many applications. I wish you luck.